All right, good morning, everybody. This is for this video today. It's going to be a way to sort of introduce and explain the activity that goes on with groundwater. And groundwater is something that's really unique. Here in Michigan, we have a lot of surface water. We have a ton of lakes and rivers and streams. We are surrounded by surface water. But in other states, groundwater is more of a necessity. Now, we do take some water from groundwater. Believe it or not, like when the snow melts, as it has been lately, or when it rains, water soaks into the ground, but it has to go somewhere. So today we're going to explore where it actually goes. And based on this information, it may change where you think you might want to store nuclear waste. So we're going to go ahead and watch the first snippet of this video, and then you'll watch the rest on your own.
We all know the Earth is full of water, but there's a lot more to water than all that blue stuff you see on the globe. The water we can see on the surface of the Earth is surface water. Surface water is every lake, pond, river, stream, and ocean on Earth. But in the ground below your feet, there's even more water, groundwater. Groundwater is water that's crammed in the tiny gaps between rocks, soils, and sediments under the ground. A full body of ground.
So this is where it gets interesting. Is where you have these now aquifers, and so water will eventually soak down through the different layers. You're looking at it's going to move through all the rocks and sand. And eventually, it's going to hit this area where it's going to settle. Now, where it settles is really unique. Everything up here is probably rocks and sand, and rocks and sand have a lot of space in between them compared to other things that are involved with making soil. Down here, you notice there's no aquifer. This really dark part down here, that's probably clay. Clay does not like water flowing through it. It will not let water actually get in between the two, in between all of its tiny, tiny particles. And these aquifers take thousands and thousands of years to form. But what happens is you have to have a permeable layer, meaning an area that where just water can flow through. So sand, rocks, dirt, all those things water can flow through, and will eventually just keep falling until it hits a layer that it can't pass, which is where you get the formation of an aquifer today. So this video today is going to give you just a little introduction about what it's like essentially to form and get groundwater, and then the reading today is going to get more in depth. So let's look at your agenda. So to-do list, watch the groundwater video. So you want to go back to this video here, jot down just 2 or 3 ideas from the video. You'll be turning this in later. And then you're also going to complete this reading. Now, the reading itself is a lot more in depth, but I do like it because it helps give you a visualization to see where these water tables are going to form. And you can see like the particle spacing and all those things. And that's what helps show you essentially where these aquifers are going to form. Now, do I expect you to fully understand groundwater by the end of this? Not necessarily, just because it's a little bit of a difficult concept to understand. But this idea of groundwater is super important when it comes to storing things underground, because many of you stated you don't want it near a water supply. So you need to understand that lots of our water comes from underground. So what I need you to do is you're going to just watch the YouTube video, jot down 2 or 3 key ideas. Then you're going to complete the groundwater reading, jot down 2 or 3 key ideas. And then we are going to go to a map. Now, the map itself looks like, let me get to it. Looks like this. So this is a map that just displays every aquifer in the country. The different colors do not have a meaning as like saying which aquifer has more water than the others. They're just here to show you where all the different aquifers are. So this is now a third map that will help you in your decision as to where you think you might want to store some of this nuclear waste. So let's look back to this part of the video here. Actually, they haven't shown it yet. So this is also another way of visualizing where all aquifers are. This is a much more detailed map. This is not as detailed, but these basically show you where all of the aquifers are located. So using this information, I need you to make a recommendation for me. I want you to see if you can figure out where you think we should store nuclear waste. So you can go back to the maps from earlier this week, but you're going to make a recommendation as to where in the United States we should store it, and then what part of the state. Is it the southern, southwestern part, the eastern part, the northern part of the state? And then I want you just to provide reasoning, and that's it. So you're going to submit your recommendation here for storing nuclear waste, and we're going to have a little bit of a discussion about it. So this is going to be a discussion. This here is just going to be an assignment. But I want you to submit your recommendation of where you think we should store nuclear waste using all of this information, okay? Because many of you stated it should not be near a source of water. Well, lots of our water is located underground. So this gives you a way to visualize where all of the water is located. So if you want, you can use this map and you can use the maps from earlier this week. So if you go back to your reading, there are two maps at the end where you guys submitted comparing and contrasting maps. You submitted something that regarded as to basically looking at what those two maps were able to tell you. So using these three maps, time to make a recommendation. Where do you think we should store it? And then last but not least, I need you to submit your key ideas from the groundwater video and the aquifer video. Hopefully this video helps with instructions. I'm looking forward to seeing and reading about what your recommendations are. Thanks.